What is ZooKeeper? So ZooKeeper is a software project of the Apache Software Foundation, which provides an open source distributed configuration service, synchronization service, and naming registry for large distributed system. So ZooKeeper is used to manage and coordinate clusters. HBase is a cluster. ZooKeeper is used to manage the HBase cluster. So it is not mandatory that ZooKeeper only manages HBase cluster. It can be used to manage any other clusters also, like any clusters where you have multiple components. But today we'll look, like when you look at the ZooKeeper today, we'll look it from the perspective of HBase, and we'll see how the ZooKeeper is used to manage the HBase cluster. So why did we need ZooKeeper? The problem is the controller, the cluster controller, it's a critical part of the system, but it does not have much relation to your application coding, right? So it does not add a lot of value to your application, but still it is a critical part of the to manage the system. It is a single point of failure, like the custom controllers that you have, right? It is not reliable and limited scalability. So we needed something which is redundant, high availability services. Those are difficult to implement and test, right? If you are going for a customized cluster controller. And admin actually need to know the setup, monitor, and recover from failures. So since we have all these problems for a custom cluster controller, ZooKeeper was developed to reduce some of this complexities. So ZooKeeper, it gives you fault tolerance. It is not a single point of failure. As we go on, we'll see that ZooKeeper Quorum, right? H Quorum peer that you said, right? In production, the H Quorum peer is formed of multiple number of ZooKeeper servers, but one of them becomes a leader. How it becomes a leader and what leader does, we will come to that point. But if the leader goes down, then one of the other peers in that quorum, right, takes the leader position and continues to do the normal functioning. So the ZooKeeper gives you the fault tolerance, right, and its high availability and redundancy is built in because of this quorum peer. So ZooKeeper, as I told, was invented to simplify this. ZooKeeper, you said the H master, right? So this is the H master, and slaves are nothing but your region server. So you have multiple masters also. One of the master is active at one point of time. There will be other masters. You can configure other masters in the queue, and they will try to fight to become the active master, right? But until one master is active, they will not be able to become master. If the active master goes down, then one of the other masters which are in the queue, right, that takes the active master position, and that's how H master also is fault tolerant. And how it becomes a master, right? How it can fight for master, how it can become a master, we'll see it soon. We'll see how ZooKeeper manages these masters and all. Okay. So how information is stored in ZooKeeper? So ZooKeeper stores information in tree-like structure. It is a traditional file system like structure, and a file is called ZNode. A file can store data and reference to other ZNode, that is its children, and each ZNode can store data up to 1 MB. Data is kept in memory and is backed up to a log for reliability. By using memory, ZooKeeper is very fast and can handle the high loads. So let me go back to Clouder again. What we'll do now is I'll start the ZooKeeper ZKCLI. I'll go to the ZooKeeper command line interface. Okay. So see, if I do a ls list, ls dash, see there's some nodes, right? I have created, this is the node that I have created. There is, this is also a node I have created, but there is a node called HBase, which was already there. There is a node called ZooKeeper. So when I say that ZooKeeper stores information in tree-like structure, this is what it is telling, that it stores information under these nodes. I know there will be a lot of questions, just follow this for a few more slides and then we'll go for the question round. So when you say tree structure, it means, okay, ZooKeeper follows a hierarchy structure, like I have nodes under nodes. So for example, under, if I go to ls Rajiv, right? Okay, I do not have a child under that, but I can create a child. Let's say Rajiv child, right? And I can give a metadata, so I can store some data under this child also. I can say my child info. So now if I do a ls, see, I can see the child node created, and if I want to see what data the child node has, right, I can say get Rajiv child. Be very attentive here, because this will clarify some of the questions we had, right? How the roots, how it stores the root server, how it gets the roots region server address and all. It will clarify that. So when I say get Rajiv child, sorry, get Rajiv child, see that my child info, I can get this my child info, and these are some things that I'll explain later. These are some of the statistics for that node. But whatever I store, right, that information I can get by doing get Rajiv child, right? So this is what it is showing, is telling us that a file can store data and reference to other ZNodes. Each ZNode can store data up to 1 MB. So this child Rajiv are nothing but ZNodes, and each ZNode can store data up to 1 MB. So this is the hierarchical structure it is talking about. So ZooKeeper data model, it's a hierarchical data model, much like a standard distributed file system. Nodes are known as ZNodes and identified by a path. ZNode can have data associated with it and children. Data is in kilobytes. ZNodes are version. Data is written in its entirety. ZNodes can be ephemeral nodes, exists as long as the session that created it is active. So that is what ephemeral node. So if I create ephemeral node, that node will exist as long as the session that created the ephemeral node exists. As soon as the that particular session goes down, right, that ephemeral node will also vanish. You can set watches on the ZNode. So any changes that happens on the ZNode, right, it will set you a watcher, send you a watcher event. Okay. Now let us do this. We have seen, ls HBase, right? So let's see what is there under the HBase ZNode. So if I do a ls HBase, right? See, I have a root region server node. I have region server. I have master, right? If I do a get HBase root region server, it gives me the region server for the root. Whenever a client wants to read a file from HBase, that client is actually first giving this command, get HBase root region server, and getting this region server location from from ZooKeeper, and then it is going into this region server to get the metadata, root table. It will go to that region server, get the root table, get the meta table address, and then it goes to the particular table. So this is how that information, that communication happens. Now we see this master, right? So if I do a get HBase master, see, this is my H master, right? You have seen in the HBase site.client, I said that it is listening on port number 60,000. So what is happening here is this master is active right now because this master has captured this master node, right? So other masters which are in queue, until and unless this master ZNode is active, is available with this value, the other masters will not be able to create this node, right? Because this node is already existing. Now remember ephemeral node, right? So this master has been created as an ephemeral node. If this master goes down, this node becomes empty. So the other masters come to know, okay, this master empty. So whichever other masters which are in queue, right, is able to create that node, right, then they become an active master. Similarly, how H master knows if a region server is down, right? So again, LS HBase, right? So RS HBase. Okay, so this is supposed, this RS, right? Region server the region server is supposed to come here. I'm not sure why it is not coming here, but this is how this region server H master knows about the region server. So this region server node is also an ephemeral node. So if one region server goes down, right? In fact, I think this is the HBase. Correct. I did the wrong thing. So, okay. So get. I have only one region server, right? I think. Let me do this. Okay. So under HBase, under region server, I have this region server here, right? And the region server location is this. Okay. Now this is a ephemeral node. This is an ephemeral node. So if the region server goes down, this particular node will go away, and H master will know, okay, this region server is no longer available. So H master, what it does is, whatever regions, right, whatever rows it had, right, it will distribute it in the other region servers. So that is how H master, the fault tolerance in H master works. If the H master goes down, the Z node will vanish because that's an ephemeral node, and other H master which are in the queue, right, they will take hold of H master. Similarly, if a region server goes down, through this ZooKeeper, this hierarchical ephemeral node, H master will know that, okay, this is not there anymore, right? Now, before I go ahead, let me see if there are any questions. So Rahul says that is why when use JPS it shows ephemeral 1 instead of JK. So Rahul, the ephemeral, if it's ephemeral or not, right? How will you know it is like this? The ephemeral owner, it's not JPS, it is LS. So whatever is an ephemeral node, right? It will have an owner. It will you will have this value. And that says that it's an ephemeral node. How you create ephemeral node is like this: create -e. Let's say I say Rajiv E, child E, ephemeral node. Okay. Now if I do a get, name node does not exist. Oh, I'll have to create the node first. Oops. Oh, okay. Oh, shit. What did it? HBase ZK CLI. Okay. Let me create -e Rajiv E ephemeral node. Okay. Now if I say get Rajiv, see it is an ephemeral node. Huh? But if I would have just said create Rajiv, not ephemeral. And then I did it get Rajiv, any, then ephemeral node is 0, right? So that is how an ephemeral node is created. I'll come to how a sequential node is also created. I'll show that to you. But now is it more clear how ZooKeeper is used in HBase? So I'll repeat. Whenever a client wants to read from a file, you have seen, right? It goes and asks the ZooKeeper. It connects the ZooKeeper through 21814. It actually executes a get root region server. It gets the region server name from there, goes to that region server, gets the root table. The root table has a meta table location. From the meta table, as soon as it gets a meta table location, meta table has everything, right? So now, can I get a quick response from the class? If it is more clear now how the ZooKeeper and the HBaster and the clients work together. So Rahul is saying that's why okay. No, where name node, data node, job tracker show that is started. Rahul, okay, Rahul, I didn't understand Rahul's question. I'll get back to Rahul soon. Vinay says ZooKeeper is GUI based tool. ZooKeeper is actually not a GUI based tool. ZooKeeper is, you can think of it as a it's a software that or a program that is you install it in a server, right? And that actually helps you to create those hierarchical node structure and all, right? So what I did is I went to the command line interface of ZooKeeper through HBase. So Vinay, if you're asking that if it is a GUI, right? Whether it's if it has a graphical user interface, I am not sure. I have never used a graphical user interface of ZooKeeper. I use usually the command line interface. So Sapnil is saying, can you explain what ephemeral node is? So ephemeral is what? Ephemeral is something which is not permanent, right? So when a region server, when you bring up a region server, when the region server registers to ZooKeeper, right? How it registers? It creates a Z node. Sorry, it creates a Z node under HBase, right? HBase RS. Under HBase RS, it will create a Z node like this. For example, right now I have only one region server, right? And that region server, it has created this Z node here. Now this Z node is an ephemeral node. What ephemeral node? What it means by ephemeral node? If my region server goes down, since the region server is the one that created this Z node, right? That created this ephemeral Z node. If the region server goes down, this node will also be deleted. So as soon as that gets deleted and the HBaster does not find this Z node, HBaster knows that okay, my this region server is no longer active. Then it does all those balancing. Similarly, as I told you, HBaster, it is fault tolerant. One HBaster is active. There are multiple HBasters in the queue who tries to become the active HBaster, right? So under HBase, you have this master Z node, which is again ephemeral. If a master HBaster goes down, then other masters which are in queue, right? They knows okay, this Z node is empty. They go ahead whichever grabs that first, right? That becomes a new master. Is the ephemeral node concept clear now, Sapnil? Okay, okay. Any other questions from the class before I continue and I show the sequential one, and I talk about quorum peer and leader, how leader selection happens. Any other questions from the class? Whatever we have seen, right? Does it give you more clarity on the architecture of HBase? Okay, Rahul says he does not have a question now. Okay. I need a quick response from the class. Ramakrishna, Venkat, Sapnil. So Durga says, please carry on. Rest of the people says, okay, so they are good. Okay. So ephemeral node, we have just seen the ZNode will be deleted when the session that created it times out or it is explicitly deleted. Sequence node is something the path name will have a monotonically increasing counter relative to the parent appended. So what that means is, if I create a -s, that is for the sequence ZNode, Rajiv S sequence ZNode, let's say, what it does is it will create a whatever number I give, right? It will give a sequence. It will append a sequence to that ZNode, right? That is called sequence ZNode. Where it comes into how it is used, I will come to that later. But that is the concept of sequence ZNode, right? Now you can set watches on the ZNode. So what watches is, it notifies the client when something changes. So for example, if the region server, right, as I mentioned, like if a region server goes down, right, and a watch is there on that ZNode. So if the client wants to read that file, read something using that region server, right, a watch event will get sent to the client. The client then will know that, okay, something got updated or something got deleted. Based on that watch event, it can take further action. But the problem with watch is it's a one-time trigger. So once the trigger has been triggered, right, then that watch is gone actually. You will have to again reset the watch, again add the watch to that ZNode. So once the watch is triggered, that is gone. That's a one-time trigger only. It's not a full-fledged notification system. It's like clients asking for recommendation. Client should verify the state after receiving the watch event. It's a responsibility of the client to verify the state once it gets a watch event. So a client will never see a change for which it has set a watch until it first sees the watch event. So if a watch is set on a ZNode and something gets updated for the ZNode, the client will not see that update before it sees the watch event. That guarantee is given by ZooKeeper. So ZooKeeper gives some guarantees. So this ordering guarantee is something that ZooKeeper gives. It says that until you see the watch, you will not see the update. So default watch, there are some default watchers also notified of state changes in the client. If there is a connection loss, session expiry, so it will get a watch event. ZooKeeper use cases in Yahoo, it is used for leader election. For example, HMaster election we have seen, right, in HBase. Similarly, in Yahoo for other clusters, it can be used for leader election. Group membership is something like related, similar to what you have seen, right? The region, when it registers to the cluster, right, it creates a ZNode. Configuration management, cluster management, load balancing, right? Use cases in HBase, leader election. HBase, HMaster is a example of leader election. Group membership, region registration is an example of group membership. So ZooKeeper nodes in HBase, these are the ones that we have already seen, right? Root, region, server, RS, master, shutdown. Whatever I just described, right, while showing these nodes to you. same thing is written here. So I'll just skip this because we know what this nodes contain. Right now, the stat structure. The stat structure is nothing but this. When I did a get, right, I got those CZXID. So what are this? So CZXID, the ZX transaction ID of the change that caused this Z node to be created. So this is the transaction ID. So whenever it is a number, it's a transaction ID of the change that caused this Z node to be created. MZXID is a transaction ID change that last modified this Z node. So if something modifies the Z node, it creates a transaction ID, and that is the transaction ID. C time is the time in milliseconds from epoch. Epoch is something like Unix as a epoch. It can get the time from epoch. So this is the time in millisecond when this Z node was created, C time. M time is when it was last modified, the Z node. The version is the number of changes to the data of this Z node. The data is nothing but the data that I appended, right? When I created /RAJV, I said ephemeral node. So the number of changes to the data of this node. C version is the number of changes to the children of this Z node. The number of changes to the access control list of this Z node is A version. Ephemeral owner tells you whether it's an ephemeral node or not. Data length is length of the data field of this Z node. For example, what that helps is, so this does not have any data, right? Let's say HBase root. So data length is 17. So 17 is nothing but the length of this data here, clouded VM60020. That is what data length is. Number of children, the number of children for this Z node. So ZooKeeper guarantees a total order of messages. What it means is whenever something gets updated, right, it has a transaction number. Those transaction numbers ensures that if an update comes from multiple places, right, multiple nodes, those updates are sequenced using those transaction number. It guarantees a total order of proposals. Proposals is nothing but transactions here. So ZooKeeper exposes the total ordering using a ZooKeeper transaction ID. All proposals will be stamped with a ZX ID when it is proposed and exactly reflects the total ordering. So whenever a change happens, like multiple changes happens, right, it will have a transaction ID. So if these changes are started from different nodes also, the transactions will order those changes. So whatever order the transaction is there, right, in that order only the client will see those changes. So before I go to ZooKeeper Quorum, any questions? So Yogesh is saying what is the purpose of this step? So statistics ZooKeeper, one is this ordering of this transaction, right? That is one purpose. So the transaction number helps to order the changes. So if the changes, the change 1 happened first, right? Then change 2 happened. The client should not see change 2 before change 1. Change 1 should be seen to client first, then change 2. So that ZXID, transaction ID, helps to do this ordering. Okay. So ZooKeeper Quorum, H quorum peer. Why it is called H quorum peer? Because in actual production, you will not have one ZooKeeper server. You will have multiple ZooKeeper server in the H quorum peer, but one of them will become the leader. One of them will become the leader because it has grabbed the leader node, right? It has grabbed the leader node. The other will be in the queue, and they will be called as followers. This server will be the leader, other will be the follower. So the clients can connect to any of those followers also. But all the updates, all the changes, all the coordination of the cluster will happen through the leader. So whatever request the server, client asks the server, that follow server, they'll pass it to the leader server, and the leader server will do the it's like a centralized coordination and centralized update. If this server goes down, if the leader goes down, again that ZNode will be empty for that particular leader. So the other servers will go ahead and grab that, one of the other servers will go ahead and grab that node and will become the leader. How the leader selection happens, there are multiple algorithms. I'll tell you one algorithm, how a leader selection happens. So all servers store a copy of the data in memory. A leader is elected at startup. Followers, service clients, all updates go through the leader. Update response are sent when a majority of servers have persisted the change. So update. So whenever a client requests, or let's say whenever an update happens, right? So this leader server will send a proposal saying, okay, this update has happened. You commit this update and let me know if you have updated it. So if a majority of the servers responds back that okay, the update has happened. So update maybe, let's say the root region server, there is another region server that got registered, right? So that needs to be updated in all the ZooKeeper servers. So once everybody or majority of them commits, says that okay, the update is done, then the leader considers okay, this is the change is persisted now, and the client can be communicated about this change. So leader selection. Before I go to the leader selection, let me see if there are any questions. So Rahul says, till now I'm not able to understand the purpose of ZooKeeper because ZooKeeper and HBase was successful execute our purpose. Please refer the real-time scenario. So Rahul, I'm not sure like ZooKeeper, where you are not able to understand the purpose of ZooKeeper here. So let me ask you this question, Rahul. If a client wants to read a HBase file, how will he know where the file is stored? Let me unmute you, Rahul. Okay, Rahul, I think you do not have a microphone. So Rahul, the question is, in an HBase, if a client wants to read a table from a table without ZooKeeper, can he do that? What is the flow? I'm asking this question because you are saying that you are not able to understand the role of ZooKeeper in HBase cluster. So one role, whenever a client, you have seen this, right? Whenever a client wants to read from a table, right? First thing you need to know is where the root catalog table is. How will you know that? You will have to, like this HBase node, right? Has this root region server node. This root region server node has the information. If you do a get HBase root, what do you see here? This is the region server location, right? So the client will get the region server location from this ZNode in ZooKeeper. Then only it can get to the table, right? So that is one contribution or one role of ZooKeeper in the cluster. The other one is under RS. What did you see under RS when I did a get HBase RS, right? Not get HBase, let me say LS. I have this ZNode here, which is the region server that is registered to ZooKeeper. It is registered here. It is an ephemeral node. So how does the cluster, if something goes down, if the region server goes down or the HMaster goes down, how will the cluster know that something is down? It will know by going to this node of ZooKeeper saying that okay, this particular thing is not there. Similarly, the HMaster, right? How will you understand the HMaster is down if that ZNode is not there? So do you understand, Rahul, like what is the role of ZooKeeper now? ZooKeeper is managing this entire cluster through this ZNode, through this hierarchical ZNode. Okay, good. So in other clusters, so as I told you, right, HBase is just one example where ZooKeeper manages a cluster. ZooKeeper can be used for a lot of other things also, for another cluster also. ZooKeeper in a cluster can be used to control your access to a resource. So what it can do is, let's say a resource needs to be accessed sequentially. So the ZooKeeper, whenever somebody accesses the resource, right, it will create a node, ephemeral node in the ZooKeeper. So that way, the algorithm can be, if that node is active or exists, that means that resource is being used by the cluster. So until and unless that ZNode clears, right, nobody else can get hold of this resource. So these are some other functionalities that ZooKeeper does in other type of clusters. Okay, so let me go ahead. So the leader selection, how does it happen? So this is one of the algorithm that I am explaining. There are multiple algorithms that exist for leader selection in case of ZooKeeper. So you saw that sequential thing, right? I'll just explain whatever is written here. So that sequential number, right? When I created a sequential ZNode, it was this Rajiv 0025, right? So all the ZooKeeper servers, they create a sequential ZNode like this, right? And then when they start fighting for becoming the leader, right, what happens is whichever has the lowest sequence number, right, that becomes a leader. That becomes the leader, and if it goes down, then the next sequence number in line becomes a leader. So this is one of the algorithm that is used for leader selection. But different setups in different clients, different clusters configuration, they can use other type of algorithm also for leader selection. And this is the diagram that we have seen some time back. This diagram explains it, the HBase, the role of ZooKeeper in the HBase cluster. So this was the last slide. So Rahul is asking question. So we can use ZooKeeper like a log file who give us information whether have error or not. That is not a good way of using ZooKeeper. For logging errors and all, Rahul, you will still be used the log files, right? ZooKeeper is used to coordinate and manage multiple components in a cluster to ensure that all the other components in the cluster behaves in a consistent manner, so that one does not step on the other, right? To manage an order of the cluster, ZooKeeper is used, and ZooKeeper does the using the hierarchical ZNode thing, right? That is the function of ZooKeeper. So if you want to control the access to a resource, sequential resource, you can use ZNode. If you want to find, if you want to introduce fault tolerance in your cluster, right, you can use ZooKeeper. So I'll pause over here and see if there are any questions from the class. Can I get a quick response from the class if you have understood the role of ZooKeeper in the HBase cluster, in managing the HBase cluster? Rahul, is it clear to you? If it is not clear to you, Rahul, I'll call you and I'll explain to you again. Okay, okay. So Yogesh says good. What about others? The other people, did you understand the role of ZooKeeper in HBase? Good, good. Excellent. So any other question? Yeah, Rahul, yeah, that's fine. Rahul says he needs time to use HBase and ask questions. Yeah. So Rahul, the MapReduce questions that you have, right? If you can just send me a mail on those MapReduce questions, right? I'll just take a look at it offline and I'll connect with you. After this class, I'll have to again prepare for another class tomorrow. So just shoot me a mail with your questions and copy the support team also there. Oh, it's a lot. So Rahul, do one thing. The first 3 important ones, send it to me, right? I'll just try to see if I can answer it to you as soon as possible. And then I'll see if I can ping you later. So any other question? Yeah, Rahul, we'll find some time which is convenient for both of us. We'll talk. Any other question? Can I get a quick response from the class? A smiley will mean that, okay, we have understood HBase ZooKeeper and we have understood HBase also. We will be able to use HBase going forward. Good. So only Durga, Rahul, Vinay, Senthil, Sapnil has understood. Rest of the people, okay. Ciao. Okay. So Mangesh, did you understand? Are there any questions from your side, Mangesh? Okay then, if there are no more questions, we'll close the session here. Okay, so that is okay. HBase, it just says HBase Master. I think we already discussed this, what HBase Master does, right? And that was the last slide. So if there are no more questions, we'll close the session here, and we'll meet in the next class. In the next class, we will go through a Java program to which will actually access HBase. We'll create a table and read data from the table, and then we'll finish the class with Scoop, and we'll describe the project for this at the course. Rahul, today I might not be able to come to Skype. I'll have to quickly get into the preparation for the next class, but we'll find a time to talk, Rahul. I promise you that. So thank you everyone. Thank you for your patient listening. I will meet again in the next class. Next class will be our last class, where we'll discuss the project also at the end. Good night. Please give your feedback as soon as I close this session. Bye-bye.